Unit 3, Lesson 5 addresses assemblies and corridors for modeling subdivision roads. In Exercise 1, you learn how to create the assembly, which is the typical section for the roadway and is created by adding subassemblies, which are the individual components of the typical section. In Exercise 2, you learn how to create a corridor model for a cul-de-sac or a road with a cul-de-sac and a subdivision. And in Exercise 3, you learn how to create a corridor surface, which can be used to model perhaps the finished design, top of asphalt layer, or the datum or the top of subgrade layer, each having their own unique purpose. In Exercise 1, you learn how to create assemblies. An assembly is the typical section for the corridor model, and it's created by adding subassemblies. So you can see here we have the assembly object, it's at this vertical line, and then a number of subassemblies that represent the sidewalk, the curb and gutter, and the lane components of the typical cross-section. And all of these subassemblies have editable parameters that allow you to control the configuration of each subassembly. So for example, for the lane you can model or change the pavement structure depth details or the width of the lane or the cross slope of the lane. When you're working in Civil 3D, sometimes it's nice to configure a workspace that shows your tool palette and AutoCAD properties windows. See, these are what you require for creating an assembly. We'll go through that. And when you create an assembly, you insert the assembly into the drawing, and then you add the individual assemblies to eventually end up with this model of a typical cross-section. So let's have a look. We've got the tool palettes window here. If I use my Control 3, I can display tool palettes. It's also displayed over here on your Home tab of the ribbon, Palettes panel. You can turn on or off your tool palettes window. A tool palettes window contains a number of palettes, and the collection, if I right click on here, the collection of tool palettes is a palette group. So this is the materials palette group, this is the samples palette group, this is the 3D Make palette group. So a number of very powerful means to organize palettes into palette groups. And so let's go back to the Imperial subassemblies. So these are the subassemblies, the individual components. That's what we see here. This is a subassembly. That's a subassembly. That's a subassembly. And when you're creating your assembly, the idea is that you want to display your AutoCAD properties window and your tool palettes window, because when you, let's turn off allow docking, when you insert a subassembly, it will populate the AutoCAD properties window with the subassembly parameters. So let's just go through and create a quick assembly here. Under under the Home tab of the ribbon, Create Design panel, choose Assembly and create Assembly, and we will call this 2-lane. And if I click OK and pick the assembly location, there's the assembly object, that vertical line. So now I can pick a lane. I'll use Lane Outside Super, and you'll notice in the AutoCAD properties window these are the input parameters. So maybe I want a 10-foot lane and this side is right. So I can now add the lane, change the side to left, and then add the lane. Now I can click the Curbs tab, Urban Curb Gutter General. This side is left, so I can pick this marker here, change the side to right, and we can add the curb over here. Then I can add Urban Sidewalk, and we can change the input parameters. So the inside boulevard width is going to be 2, the sidewalk width is 5, and the outside boulevard width is 1. This side is right, so we'll place that one right here. And we'll change the side to left, and we'll place that one there. So that's how you essentially make an assembly. It's fairly straightforward, but the nice thing about this is that if you pick a subassembly, you can modify the parameters in the AutoCAD Properties window, change the width to 15, and now I've got a 15-foot lane on the right-hand side. So these are some completed assemblies. If we look at the tool space window, your assemblies are collected in Prospector on the Assemblies tab, and these are the two assemblies that we have created. And once again, you can navigate to these assemblies. So these two assemblies are used to model this corridor that you see here. I'm going to go through that shortly. In exercise 2, you learn how to create the corridor model from the assemblies. Now this is a fairly complex, let's say, approach to corridor modeling. Modeling a cul-de-sac is not a straightforward application, but we can go through some definitions. The baseline is used to model a corridor, and a baseline is the alignment and the profile that you hang the subassembly off of. So the first baseline is this line here, the center line. So up until the cul-de-sac, you model the cross section, or you model the corridor using this alignment and this profile, and then a typical section. Then when you get to the cul-de-sac, you use this alignment and this profile, and that's where you process the half section. So there's different components to a corridor model, and if we look at that quickly, here's the corridor model, and if I go to corridor properties, the highlighting here will make this a little bit easier to understand, but here's my parameters. So my first baseline is the Cedar Cove center line, and that's that. The second baseline is the edge of pavement. The first region is this part here, so I'm only the region is the application of the cross section or the assembly over a station range. And here's the second region. So first baseline, first region, second baseline, second region. So a little bit of a complicated example from a corridor creation perspective, but you know, we're not designing simple roads out there very much. We are designing these sorts of things. So essentially what we do is we take this typical cross section here, this is the full section, run that along the alignment profile for here up to this point here, and then we take this little half section and we run that around an alignment and profile developed for the edge of the pavement here. And that's essentially all this data that you see over here. So the baseline is the alignment, the profile, and the assembly used to model a corridor, and you can have multiple baselines. And a region is the application of the assembly over a specific station range. And the assembly insertion frequency is the interval along the alignment at which the assembly is inserted to model the corridor. And that's this interval here. So if we were to go back to the corridor, let's have a look at the corridor again. Go to corridor properties. You can see here the assembly insertion frequency for the first baseline is every 10 feet. Well, if I change that to every 5 feet, watch what happens. Let's click in here again. And let's go 5 feet along the tangents. Watch what happens with the increment. It just gets a little bit denser because we've processed that every 5 feet along that section. So when you look at the final corridor object, you have the corridor here. If we go into the object viewer, which is the three-dimensional viewer, and look at this in an isometric view here, let's maximize the screen so you can see it a little bit better. But there is how we've modeled the corridor. So this is the assembly inserted every 5 feet in this case along the tangent sections. In the third exercise, you learn how to create corridor surfaces. Typically, you would create the datum surface for volume calculations, and you would create the top surface for calculating elevation and slope labels or pipe rim invert elevation calculations. And the datum links are these red lines along the bottom, and then the top links are these blue lines along the top. So you can create the surface from any links, but typically you're either going to create a datum surface or a top surface. And it's important to use surface boundaries to contain the triangulation. So let's just quickly do that. If we pick the corridor and go to corridor properties, and under the surfaces tab we don't have any surfaces created, we can create a new surface. So this is going to be called Cedar Cove Datum, and we're going to build that surface from the links, and we'll use the datum links, and then we'll hit this plus button to add that data, and then we'll display that surface using a triangle style. So when I click OK, you can see there is the surface. That's the actual datum surface. And if I go to Prospector, under the surfaces tree, you have the Cedar Cove datum surface. You can see it's a corridor surface because of the symbol here. Now the problem is the triangulation lines extending beyond the limit of the corridor. Well, that's what we can do, is we can go to the corridor here and modify the properties of that corridor. And under the Boundaries tab, we can add the corridor extents as a boundary to that surface. So that's just a right click, add corridor extents as outer boundary, and it's essentially a corridor shrink wrap. If I click OK, you can see now the triangulation is contained within that datum surface. And if you wanted to, we could draw a line across here, pick the line, right click, and do a quick profile, and show the existing ground in Cedar Cove datum in a profile view. And you can see here's the datum surface. Now, something that we didn't really get into the curriculum are these spikes, and we can clean that up if we modify the corridor properties, and under the surfaces tab we can fix the overhangs using bottom links. And this is something a bit more of an advanced feature that we don't get into the curriculum, but that's what's causing problems with the datum. And it essentially has to do with the fact that it's trying to triangulate. You cannot triangulate two elevations at one location, so it's getting a little confused in this area here. So we can fix that up using the overhang option. And that concludes the lesson on assemblies and corridors in Unit 3 for land development.